Today we continue our look at quadratics and finding the roots. We're going to start with the warm-up. A graph has x-intercepts at -1 and 5, and the graph is twice as skinny and bold down. Write an equation for the parabola in factored form and in standard form. All right, I'm going to underline the important information before we write the equation. We have the x-intercepts at -5 and 1, twice as skinny and bold down. All right, so our equation right here, let's write the factors first. So we know that the factors are the opposite of the zeros, or x-intercepts. So one factor would be x plus 1, and the other factor would be x minus 5. If it's twice as skinny, it's like saying the slope is 2. And if it's bold down, we'll stick that negative in front. So if we take a look at this, you should be able to, since it's in factored form, realize that there are two x-intercepts, plus it tells you right here. The x-intercepts are -1 and 5, so it has two solutions. And then it says, what do the answers of the quadratic formula tell you? So if you were to use quadratic formula, which we've been using the last few days, the quadratic formula gives you the zeros, the roots, and solutions. So it gives you the actual roots, the solutions, the zeros of the graph. If you remember, the discriminant tells us how many solutions there are, but again, when you actually use quadratic formula, that gives you the actual answers. All right, let's do some review here. Solve each equation by factoring, and then simplify your answers as fractions. And then we're going to review quadratic formula, and then we're going to review the axis of symmetry and how it's related to what we just did. So first factoring, remember you need 0 on one side first. So you have x squared plus 6x plus 8 equals 0. And this one we can use a box and circle to solve. So if I stick it in my box and circle, we have x squared, 6x, and 8. We want to know what multiplies to the first number and the last number. So multiplies to 8x squared. That adds to our middle number right here, 6x. So some factors of 8 would be 4 and 2. And that also adds up to 6. So we have x plus 4, x plus 2 equals 0. And then if it says solve, we have to go a step further. So again, it says solve right here. Let's change colors. And so we use zero product property. What makes x plus 4 equals 0? -4. What makes x plus 2 equals 0? -2. So here are the actual solutions or roots. So we factor, set each factor equal to 0, and solve. All right, let's try the next one. I'm going to erase some of my work here. Okay, so again, you want to get 0 on one side, so we have 2x squared plus 5x minus 3, so I put it in standard form right there, equals 0. Again, let's put it in our box. So we have 2x squared, 5x minus 3. All right, we want to know what multiplies to -6x squared. That adds to 5x. All right, some factors of -6 would be -2 and -3, but they don't add to 5. How about 6 and -1? That works. 6x, -1x. They multiply to -6, add to 5. Let's factor the outside. We know we have an x and an x, but we have, let's see, a 6 here. Actually, what multiplies to 2x squared? Let's put our 2 right here to get the 6 plus 3. X times -1 is -x. So we have 2x minus 1, we have x plus 3 equals 0, and we want to find the zeros. So one of them is pretty easy. We know that -3 makes x plus 3 equals 0, but the other one, if you don't know, you set it equal to 0 and solve. So we're going to add 1 to each side. 2x equals 1, divide by 2, so we have x equals 1/2. So there are the zeros. All right, let's say you didn't like factoring and didn't like the box and circle. We can use quadratic formula to solve. So again, first step, you do need 0 on one side. So if we rewrite this next one, we have x squared plus 6x plus 8 equals 0. Identify a, b, and c. A is 1, b is 6, c is -8, or +8, sorry. All right, plug into quadratic formula. X equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. So there's the first step, plug in. Second step, figure out your three chunks right here. We we have x equals negative 6 plus or minus. I want you to figure out the discriminant, calculate that. So for this case, it's 4 over 2, which gives us negative 6 plus or minus 2 over 2. We get two answers. Negative 6 plus 2 is negative 4. Negative 4 divided by 2. Actually, let's do this differently. Okay. And you'll see why once we go over the next question. So I'm going to take each term and divide it by 2 here. So we have negative 3 plus or minus 1. And then we get our answers. Of course, we had it above. We had negative 4 and negative 2. Negative 3 minus 1 is negative 4. Negative 3 plus 1 is negative 2. Okay, let's do that here, and then we'll go over what does that have to do with our axis of symmetry. Okay, so again, identify A, B, and C. So remember, get 0 on one side. So I'm going to look at this part of the equation here. And A equals 2, B equals 5, C equals negative 3. Let's double check. Yep. All right, plug into quadratic formula. X equals opposite B plus or minus the square root of B squared minus 4AC. Squeeze that negative 3 in there. All over 2A. Again, calculate the discriminant, your 3 chunks. So we have 5 squared minus 4 times 2 times negative 3, which is let's see, I calculated that before. Let's do it again. 5 squared. Let me double check. Okay. 5 squared is 25 minus 4 times 2 times negative 3. 49. Okay, so this is 49. All over 4. And then again, I am going to split this up. We know the square root of 49 is 7, but let's split this up this way. So we get x equals negative 5 over 4 plus or minus 7 over 4. And then we can solve and get our zeros. So two answers will be 5. Let's see what we got here. Negative 3 and 1/2 is our answers. Negative 3 and 1/2. All right, now the reason why I split this up is because then the next question asks, what is the axis of symmetry for each equation? So the axis of symmetry we've practiced before when we've graphed by hand. The axis of symmetry is the middle of our zeros. So for example, let me sketch. I know it's getting kind of messy here, but if I graph this, we have our zeros at negative 4 and negative 2. So here's negative 4 and negative 2. And if I sketch this quadratic, the axis of symmetry is smack dab in the middle of those. And so to figure that out, we talked about how the middle is the average of the two numbers. So if I say negative 4 plus negative 2 divided by 2, that's negative 6 over 2, which is negative 3. All right, look at where that negative 3 is. Oh, it's this part right here. It's this opposite B over 2A. So here the axis of symmetry, the first one's at negative 3. The second one, again, if we find the middle of our zeros, the middle of these guys right here, negative 3 and 2. Use blue here. If you find the middle of this, negative 3 plus half, and then divide by 2, we get this negative 5 over 4, or negative 1/2. So again, we'll talk about that. This is kind of just building the idea. But if you have that opposite B over 2A, that's that middle, that line of symmetry for your equation. Okay, but that actually is another day, so we just reviewed. Okay, more review here. How many real solutions does a quadratic have and when? We look at something called the discriminant. So the discriminant, okay, so the discriminant is that b squared minus 4ac, which we have right here. And when the discriminant is greater than 0, you have two solutions. And the reason why is you get two zeros, right? So you have your number, your opposite b, and you add or subtract a number, divide by 2, and you get two answers. When that discriminant, this is getting messy here, okay. When the discriminant equals 0, you only have one solution, and the reason is you have your opposite b, but you're adding 0 to that. And so when you have that plus or minus, it doesn't really matter. You just get one answer. And when your discriminant is less than 0, you have 0 real solutions because of this. If I give you like the square root of -3, there's not a number that you can multiply by itself and get a negative. So there's 0 solutions when the discriminant is negative. Okay, so this was this negative, this means it's positive, and this means it's 0. Oops. Okay, so again, to summarize, when your discriminant is positive, you have 2 answers because you have your plus or minus a number. When your discriminant is 0, you have 1 answer because plus or minus 0 is the same thing. And when your discriminant is negative, you have 0 real solutions because you can't take the square root of a negative number. All right, the next one, solve x squared plus 2x plus 5 equals 0. If that doesn't seem to factor, use quadratic formula. All right, so again, what we're looking for is what numbers multiply to 5. If I put it in our box and circle, x squared, 2x, 5. All right, what multiplies to 5, x squared, that adds to 2x, and the only factors of 5 are 5 and 1. So this one, again, it says doesn't seem to factor. No, it doesn't. So let's use quadratic formula and see what happens. So here we have a is 1, b is 2, c is 5. X equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. So we have x equals opposite b plus or minus the square root of, here we have 4 minus 20. This is negative 16 all over 2. All right, how many solutions does it have? Well, this is telling us it has 0 real solutions. So let's graph this and see what it looks like.
Abdi Salam, if you're in the building, can you please swing back to the student office? Again, Abdi Salam, please come to the student office.
All right, so we have x squared plus 2x plus 5. Let's graph this and see what it looks like. And you can see, yep, it doesn't have any real solutions here. It doesn't cross the x-axis. And so if we sketch the graph of that, it looks something like this. And it doesn't touch your x-axis. Let's actually make this bigger now. So 0 real solutions. Explain why there are no x-intercepts while your graph doesn't touch the x-axis. Okay, when the discriminant gives you a negative answer, we know there are no real solutions. However, and we can see that because the graph doesn't touch the x-axis. However, there are 2 imaginary solutions. When there's a negative number under the square root, you can still get solutions, 2 solutions, and it can be simplified by using imaginary numbers. When you solve the problem above, here's what we got. We have that negative 16. And again, why can't we solve negative 16, the square root of negative 16? Well, there's no number times itself. That's negative 16. All right, so that's the problem. There's no real solution, real number that satisfies that. But mathematics expanded the number system by creating imaginary numbers to accommodate that need. So there are 2 imaginary roots. And to get that, this imaginary number is the square root of negative 1. And if we multiply the square root of negative 1 times the square root of negative 1, we know that we can multiply the 2 numbers under the radical together. We get the square root of 1, which is 1. And so, therefore, if we do I times I, that equals, oh, this should be a negative 1. Well, actually, no, I'm going to explain it a different way. So if we multiply any number times itself under the radical, we get that number underneath, negative 1. And so I times I is negative 1. So for example, if I do the square root of 3 times the square root of 3, we get the square root of 9, which is 3. So again, any number radical times itself, the radicals cancel and you get the number underneath. So when you have the square root of negative 1 times the square root of negative 1, we get negative 1. It becomes a real number if you multiply it by itself. So here's what this is saying. Again, when you have the square root of negative 1 squared, or I squared, that equals negative 1. So for today's lesson, whenever we see, this will be the important part right here, the square root of negative 1, we change that to an I. And if we have I squared, that equals negative 1. And we'll spend 2 days looking at that. All right, so earlier we got the square root of negative 16. Again, we can split that up, square root of negative 1, square root of 16. Pull out that I, and then the square root of 16 is 4. And then when we rewrite this, usually we put the number first, so this is 4i right here. So again, any negative square root, we can now simplify by pulling out the imaginary number, and then we can simplify further. So here's some examples. The square root of negative 25 is, pull out that square root of negative 21. That becomes an I, and then the square root of 25 is 5, and so that's 5I. The next one we have, again, let's pull the square root of negative 1. Pull out the biggest square number from 18, and that's 9 and 2. Well, 9 is the biggest square number. So this is I times 3 square root of 2. Or we can rewrite that as 3 square root of 2, and then I. And the last, two more. Again, pull out that negative 1. Here, 4 is the biggest square number. You can divide 8 by. I times 2 square root of 2. And then we have 2 square root of 2, and we'll pull that I out on the outside. And the last one, the square root of negative 3. There's no square numbers you can pull out, but you can pull out the I. So we have the square root of 3, and then I. So for today, if you get a negative under the radical, basically you pull out the I, make it positive, and then simplify the radical further if possible. So this shows the steps right here, that square root of negative 16, we got as 4I, and it's showing you can simplify a step further right here. So we have negative 2 over 2 plus or minus 4I over 2. So they're just splitting up the fraction like this. And we get negative 1 plus or minus 2I as the most simplified form. So two answers, negative 1, if I write this negative 1 plus 2I and negative 1 minus 2I, those are the two imaginary roots. Okay, so last, we're just going to practice this right here. We're going to solve x squared minus 2x plus 3 equals 0 using quadratic formula. So first identify a, b, and c. A is 1, b is negative 2, c is 3. All right, use quadratic formula. X equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. Solve for your three chunks right here. This one, these, and these. We get x equals 2 plus or minus the square root. You type that discriminant in your calculator, and we get negative 8 over 2. Here's the new part. That square root of negative 8 we're going to simplify. So we get x equals 2 plus or minus the square root of negative 1, square root of 4, square root of 2. So we did that actually above. And that equals, write it down here. So this is your I, this is your 2. So x equals 2 plus or minus 2 times the square root of 2i over 2. And then you can break it up. So this becomes 2 over 2 plus or minus 2 square root of 2i over 2. So here we have x equals 1 plus or minus the square root of 2i. Two solutions, one plus the square root of 2i, the other one minus the square root of 2i. Okay, let's try another one. And erase some of this. So again, identify a, b, and c. So here a is 1, b is 3, c is 3. Plug into quadratic formula. X equals opposite b plus or minus the square root of b squared minus 4ac all over 2a. Calculate your three numbers here. X equals negative 3 plus or minus the square root of negative 3 over 2. Pull out that I. X equals negative 3 plus or minus the square root of 3i over 2. And that's the furthest we can simplify it because we can't divide 3 or 1 by 2, so I'm just going to leave that. And the last one, again, identify a, b, and c. So a equals negative 2, b equals negative 4, c equals negative 5. Plug into quadratic formula. X equals opposite b plus or minus the square root of negative 4 squared minus 4 times negative 2 times negative 5. Whoops. Squeezing that negative 5. All over 2a. Calculate your discriminant, your three parts here. So 4 plus or minus the square root of negative 24 over negative 4. Simplify that radical. I'm going to do this in a separate step. So negative 24 equals the square root of negative 1. Square root of 4 square root of 6. So this becomes 2 square root of 6I. So here's the I, here's the 2. And then plug it back into quadratic formula. So x equals 4 plus or minus 2 square root of 6I over negative 4. All right, now I'm going to split it up, and we're going to simplify. X equals 4 plus 2 square root of 6I over negative 4. X equals 4 minus 2 square root of 6I over negative 4. And then again, you divide each term here by negative 4 here. So we get x equals negative 1 minus 1/2 square root of 6I. And x equals, this is negative 1 plus 1/2 times the square root of 6I. All right, so those are your two solutions. Again, the main idea here is you want to pull out the negative as an I when you see the square root of negative 1, and then simplify your fraction after that. So that's the new part. All right, tomorrow we'll take a second look at I and look at operations. Or tomorrow we'll look at operations with I.